Hello everyone. In this video, I'm going to discuss some of the previous year questions. So here I have collected some previous 4 years question papers, the 23, 24, 22, and 21, and how that question paper questions appeared. See here one of the sample question paper, and all the questions are objective type, and some of the questions you need to solve and you need to get the answer, mathematical related and all. So time management also it is a crucial factor here. So here let us dive into the questions. So first question it is of the supercomputer related. So Pratyush is the dash fastest supercomputer in the world. So here we have a Pratyush, it is one of the supercomputer. Is the configuration of this computer. It will be having a very heavy configuration here. Speed it is of the 6.8 petaflops and cost of the computer is 450 crores. And features processor and memory. Memory it is of the 414 terabytes. So it is very large. That usually in our system it will be of the 1 terabyte. 1 terabyte, 2 terabyte like that we can notice. But here it is of the 414 and storage capacity 27 petabytes it is. And here we have a clock speed, it will be of the 2.1 gigahertz. So as it is having the very heavy configuration, it is a supercomputer here. Here we have a Pratyush is India's fastest supercomputer and it is used for weather forecasting. The main objective of the computer is for the weather forecasting and climate research. It is used in the research field of the climate itself. And it's located at the Indian Institution of Tropical Meteorology, that is IITM in Pune. Pratyush was inaugurated on January 2018 by Dr. Harshvardhan, the Union Minister for Science and Technology. Pratyush is India's fastest supercomputer and ranked among the top 100 globally. And we may say it is the fourth fastest in the world for weather and climate research. That's what the correct answer for the Pratyush is. It is the fourth fastest supercomputer in the world here. The second question is, the main purpose of time sharing techniques used in computers is to make the best use of first one, central processing unit, and second one is the peripherals, third one secondary storage, and fourth one floppy disk. So here we have a first of all peripheral device. What do you mean by the peripheral device? Peripheral devices are nothing but any external device which is connected with your system to give some service. So it is not a software component. It is a device which is connected to the computer system. It may be of any of the input output hardware devices, that is a keyboard, mouse, or any of the storage device, pen drive, something. So all these are called as the peripheral devices. So floppy disk, a removable magnetic storage medium used to store the data on computers. So that is called as a floppy disk, yeah, removable storage device. And next one is a secondary storage, that is a permanent, that is a non-volatile. Once the data is written in the secondary storage, that will be permanent. So inbuilt secondary storage in computer is the hard disk. So once the power goes off, no data, it will be deleted, removed from the secondary storage. Once it is stored, it is a permanent. The next comes the CPU, Central Processing Unit, which is the heart of the computer, brain of the computer. It's a chip that performs the core operation on the computer, like running programs and executing instructions. In order to execute the instructions, must ensure the CPU it is required. CPU itself, it will be controlling, cooperating each and every activity of the computer system to perform the particular task here. So here we have a CPU. CPU, it is a very prominent device, very important device here. And in each system, we'll be having a single processor. That is only one CPU it will be having for the normal use. In that CPU time, it is very fast comparing to that of the user time. So being a user, we are having 1 second as the minimum time. But in computer system, the processor time, it will be calculated in terms of the nanoseconds. So 1 nanosecond equals to 10 raised to minus 9 seconds. Means here 1 second itself it is divided into millions together times. In that 1 unit it is a system time unit, that is the processor time unit. So processor is having capacity to do many of the tasks in 1 second. But as a user, we are giving request means that one request in minimum in 1 second it will be going. So here the waste of the processor time, that user speed it is very low and computer speed it is very fast. To balance this one, here we have a different techniques. One of the technique it is the time sharing. Time sharing means in this we have a it is a technique that allows multiple users to interact with the computer system simultaneously, giving each user the impression that they have dedicated users to the CPU. Means here, being a user, I can go for the multiple tasks. I may go for the browsing. At the same time, I am doing some program here. At the same time, I am sending the mail. I may go for the multiple operations here. So multiple applications I'll open and I'll go for the different work. These are the different works I am performing in the computer system. And for each and every work, it is giving the immediate response. So being a user, I feel it is a simultaneous execution. But processor, what it will do, it will be dividing its time into different users. That it will be divided the time into different users, different time slices here, quantum, and that service it will be given for the multiple users. So here we have a time sharing operates by dividing the CPU time into small segments. That is the time slices and allocating these elements to different users or programs. Users are nothing but programs. We can represent programs with a user in a round robin fashion. Round robin means suppose now we have a four users are there. They are performing different tasks. Here we have a processor time. It is 20 nanoseconds. Maximum processor time to complete the task. It is 20. So among four users, how it is dividing means maybe the time quantum it is 5. 5, 5, 5 it will be giving. And again the remaining time it will be divided into 5, 5. So here for each user, 5 unit of the processor time it will be spending. After completion of one cycle, again it will take the repetition. This is how it will be divided into number of users. That is the round robin fashion. Because the CPU switches between these users programs very quickly. So here we have a context switching. Switching of this processor between all these users are very fast because the processor time it is very fast. For processor, it is a one by one execution. That is a concurrent execution. But being a user, we can notice that it is a simultaneous execution. Means processor is giving only the output, the response for one user like that it will be treated here. So users experience the system as if they have exclusive access to the CPU. Means even in internet we can notice we are millions together users are accessing the particular site and everyone will be getting the response immediately. It is a single site but response it is immediate for all. So as if we feel it is only for us. When the result comes, all students are rushing for the same site and that each and every student will be getting the result immediately, that as if the system it is giving response only for my question I feel here, but it is giving the service for all the users who are accessing simultaneously. This is why the processor time it is very fast comparing to that of the user time. So here we have a multi-programming and multitasking. Because of the time sharing, it is nothing but an extension of the multi-program and multitasking. So time sharing is an extension of multi-programming where multiple programs can be loaded into memory and executed concurrently in time sharing. In time sharing, the operating system manages the switching between these programs, providing each with a time slice on the CPU attention. The time sharing, it will be dividing the time of the processor and it will be shared among the multiple users. And all the multiple users execution, it will take simultaneously in the parallel execution for the user point of view. Then now here we have a efficient resource utilization. By doing this one, by implementing the time sharing, The main advantage is efficient resource utilization. One of the most important resource of the computer is the processor, CPU. Without CPU, we cannot do anything in the system. And without efficient performance of the CPU, we cannot get the immediate response. We cannot get the processing. So here we have a, as the processor time, it will be divided into that. Here it is very fast without wasting the processor time, that it will be implemented for the one or the other task, that it will be implemented, that it will be possible with the time sharing. Yeah, that's what proper utilization of the CPU. It is a main objective of the time sharing. So here we can notice multi-programming and multitasking. How it is performed, multi-program means here we have a, first of all, here we have a different task. We can notice the task here means different users, user 1, user 2, user 3. That one of the operation, it is the browsing, another operation accessing the VS Code for writing code and all. And one more, we have a Discord where we can go for other activities and all. And one more, we are sending the email. So here we have a single CPU. It is required to manage all these users. So when the execution of these users will be taking in the computer system, here each and every task, whatever we have taken here, that it will be divided into different programs, small program chunks. These are called as the processors. That P1, P2, P3, P4 are the processors, means the division of these users in order to perform the task here. Here, for example, now in VS Code, we are writing one of the program which may go for the addition, subtraction, multiplication, and division. Here we have a 4 tasks, and these 4 tasks are divided into programs here. That is addition, subtraction, multiplication, and division, and all. And like that only, here we have a email. That processing of the email it is taking means it may go for any of the process here. Like this, when these are coming for the execution, they are divided into processes. And these processes are executed by the CPU. CPU, it will be executing processes, and these processes are executed parallelly. So we feel that these are the simultaneous executions. So here we have a CPU, it will be switching. When the execution of these programs it will be taking, the CPU has to switch between all these users. Once it is switching to the browser, and it will be performing certain amount of the time here. Time quantum may be 5 nanoseconds. 5 nanoseconds work it will be completed, and depends on the priority. It may go for the Discord here, and it can perform the activity whatever it is expected by the user. And then it may switch to the email. Then it may come to the VS Code once again for the execution. Like this, the single CPU, it will be switching between the different operations. This it is called as a context switching. And by doing this context switch, it will be performing of all these programs. This it is called as a multitasking. Multitasking as well as multi-programming. This portion, it is a multi-programming, and this is a multitasking. Then next here we have the same thing. The CPU, how it will be switching between the different users. Here we have a different users, different applications which are accessing with a single processor. That processor, it will be sharing the time among all these, and it will be performing the task. So here we have a correct answer for this question. It is nothing but a CPU. Now it is clear. The main purpose of the time sharing technique used in computers is to make the best use of CPU, central processing unit, because single processor can perform the multiple tasks, and one task will be performed at a time with the processor. That's what processor time, it is very fast, and users it is very slow. That time it will be divided into different times, the time chunks. That is called as the time sharing. Then next question is, joystick is primarily used to for control sound, draw pictures, and computer gaming, and enter text. So here we have this is a joystick. It is one of the input device. So this device, it is mainly meant for the computer gaming. A joystick is a manual control, typically consisting of a handle or stick. that pivots on a base used as an input device to control the movement or actions of a digital object on a screen, especially in video gaming. So when the rotation of this handle it will be taking, that rotation of the handle, it will be moving the point in the pivotal area, means randomly that point it will be moved, and that it will be controlling the movement of the object on the screen here. That's what specially it is. Typically, it is meant for the video games. The answer for this one is a computer gaming. The next question is, which of the following is the largest units of storage? Here it is given terabytes, megabytes, kilobytes, and gigabyte. So before finding answer for this, we'll have a clear idea about the unit of allocation. So in computer system, the screen, that the memory allocation of the computer system, it will be divided into different partitions that cells. Each cell it is having the capacity to allocate one of the binary value that it is called as a bit. One cell it is a bit here. Like that combination of two 8 cells, it is called as a byte here. So here we have a 1 bit, it is having 0 or 1. Combinations of zeros and ones, 8 zeros and ones, it is called as a byte. For 8 cells, it is required here. So here we have a 8 bits equals to 1 byte. And like that only, kilobytes, 1024 bytes equals to 1 kilobyte. And 1024 kilobytes equals to 1 megabyte. 1024 megabytes equals to 1 gigabyte, and 1024 gigabytes equals to 1 terabyte. Like that only 1024 terabytes equals to 1 petabyte. 1024 petabytes equals to 1 exabyte it is. And 1024 exabytes equals to 1 zettabyte. And 1024 zettabytes equals to 1 yottabyte. This is how the memory it will be counted here, the increasing order of the size of the memory. So here we have a given terabyte, megabyte, gigabyte, and kilobyte. So kilobyte, 1024 bytes equals to 1 kilobyte here. 1024 kilobytes equals to 1 megabyte. 1024 megabytes equals to 1 gigabyte. 1024 gigabytes equals to 1 terabyte. So the highest memory storage, it will be of the terabyte. And the lowest is the kilobyte here in the given answer. The next question is the use of a combination of ones and zeros in the feature of which of the following type of the computer language? So computer languages, we can bifurcate into two types here, machine level as well as high level programming languages. So here we have a high level programming language. It will be having zeros as well as that all the characters, symbols, numbers, everything. That is a natural language, common English language. Whereas the low level language, it is a computer language. Computer can understand only zeros and ones. Means it will be reading the information, whatever information we are giving, that it reads in terms of the voltages. It is a high as well as low. High voltage, it will be indicated with a 1, and low voltage, it will be of the 0. That's what machine language, it is a 0 and 1. The answer for this one, it is a machine language here. And along with that, we have a different languages, Pascal, COBOL, and high level, all it is given. What do you mean by this Pascal? Is a procedural programming language. It is a procedural. Usually in programming language, we have a procedure oriented as well as object oriented. So that almost the traditional languages are comes under the procedural format here, and developed in 1970 by Nicholas Wirth and designed to teach structured programming and good coding practices. This is one of the traditional programming language. A high-level programming language is a common English language, that human language it is, which it will be reading, writing in terms of the human language. Then COBOL. COBOL stands for the Common Business Oriented Language. It is a high-level English-like programming language designed for business applications, particularly those involving data processing and financial system. And then last we have a machine language. Machine language is nothing but it is main feature of the machine language is it is a machine dependent. Means if I have written any of the program by using the machine language in one program computer system, that different architecture platform it is taken means it cannot be supported. Machine dependent it is, and purely it will be written in the zeros as well as ones. That's what the answer for this question. It is the machine language. So these are the some uh, questions related to 2023 we had discussed here, and further questions I'll continue in the further videos. Thank you for watching.